Okay, we're going to model the pumpkin tossing contest problem on our calculators and see what it actually looks like in real time here. So let's take a look at our parametric equations. They're the same ones that we used when we did the problem on our paper. And we need to make sure our window is correct. So our Tmin will be 0, our Tmax 6, because it took about 5.79 seconds for it to hit the ground. I'm going to take that T-step of 0.01 that's in there now is probably going to be really slow, so I'm going to go with 0.1. And I made the X-min -5, the max 525 because the pumpkin went, we figured that it went about 512 feet, so that'll take care of that. I made the scale 10, no big deal there. You could make it 1, it doesn't really matter. Y minimum is -5, Y maximum I left to be 200. I just took a guess at how high it went. We didn't really know. So now let's take a look at the graph. And that went pretty quick, but I'm going to show you something here. When you go to Y equals, I'm going to arrow over to the front of the equation and hit enter. And here we have the option to change the color of the graph, which I don't really care about, but I do care about this. We're going to actually change this line to, instead of a fat line, we're going to go to a line with a circle, which basically means it's going to grab a little, what looks like a ball or a pumpkin or whatever. It's going to have a trailer line behind it. So we'll hit OK. And now watch what happens when we hit graph. The little circle thing is going to slow it down a little bit. And also you get to kind of see the thing flying through the air. And there goes the pumpkin. And you can see, now you can hit trace, figure out its height at any time. T, you could go, like if I wanted to know the height of the pumpkin after 4 seconds, I can hit 4, and you can see that's where the pumpkin is. This actually shows the path of the pumpkin, the actual true path of the pumpkin. It gives its X, Y coordinates at any time T. So that's pretty cool.